Welcome to our new series called Conversations with Alumni. In this series, we will be talking to our alumni about their life journeys. They will share with us their experiences, learning, and achievements. For our first guest, we have Dr. Kartik Sheth with us from the batch of 1987. Dr. Kartik Sheth is a program scientist in the Science Mission Directorate at NASA headquarters. He works in the Astrophysics and Earth Science Division. Before joining NASA headquarters in 2015, Dr. Kartik was tenured astronomer at the National Radio Astronomy Observatory, where his research focused on the assembly and evolution of galaxies. Dr. Sheth is also the founder and president of the Empowered Earth Alliance, a non-profit that catalyzes development of sustainable solutions by empowering local leaders with problem-solving skills. In his spare time, he enjoys traveling, biking, and cooking new vegan dishes, and in general, causing trouble wherever he goes. Without further ado, let's hear from Dr. Kartik Sheth
And
himself.
really happy to be here. Jennifer introduced me, and I want to let's see. Can you see my slides? Give me a thumbs up. Yeah,
Yes.
good. Thank you. So sometimes when I tell people about where I come from in America, I always have to show them, a map of India, and then I usually zoom in and I say where I grew up in Mumbai and then Mulund. So I grew up on Zavir Road, which you're probably all familiar with, right across from the Jain temple, in Pushpamani building. Our old Sharon English High School, my junior and senior kindergarten were just like one block away. I don't know if it's still there, but so that's my family, my parents and my sister, and that's me on the right. I know I look exactly the same, so and that's a picture from 1980 when I think we went to Kashmir for the first time. So here's a fun picture. Thinking about Sharon, I pulled up all kinds of photographs. I think this was I don't even know what standard I was in, but probably third or fourth standard. Uh, can anybody? I know it's too many of us, but if we were in the room together, I would ask you to see if you can find me in this picture. But I'll just point out to you, that's me right there. I was always one of the shortest people in the class, so you can always find me because except for Niranjan, I was always the shortest person, so I would be easy to identify. One of the great things about Sharon is this is all of us from that class of 1987, 25 years later. And, I think you have to remember that when you go to school, of course, you're going to have a few really good friends. But I think one of the things Sharon really taught me was just the value of good friends and good friendships and how we all still support each other even after all of these years. So that's me again. And it's kind of fun to go back and forth and match people to see who's in the previous picture and who's in this picture. But many of these people still live in Mulund, so you might see them. Rajesh lives in Mulund East, and Rajiv's one of my close friends, and he lives near Armal. And then my closest friends are Rajiv and Anup and myself. So the three of us live very close near Zavir Road. So for me, what are my memories of Sharon English High School? This is an old photograph. I don't know if even Jennifer, you knew about this photograph. Or you've seen it, your grandparents. So Sir Philip uh, and Madam here really taught me a lot of discipline. And very important part for me growing up and going through Sharon was service to others. So we had a service day in school. I hope you still do it. And the amount of time that we give back to the community, because no matter how poor we were, we always thought we could do something for society. And so that was really important. So I just put a couple of certificates I have from back during the school days. We did a matchbox collection to collect money for the blind and money for senior citizens. So it's just, I have so many good memories of Sharon being such a big school, such a big part of my upbringing. Respect for
Karthik,
teachers. Yeah, go ahead.
sorry, can I interrupt you? I think your screen is not max, it's not in the full size. Could you maximize it? We're
I
not
can
able to
try. I
see.
was having this trouble. Is that better or not good?
Yeah,
No?
this is better. This is better.
Okay.
Yeah, thank
Let me
you.
see. Am I sharing, can you see my desktop, or are you just seeing the screen?
Yes, we see your
Hang on.
desktop in the background.
Let me try it again. Well, thank you for interrupting me. Let's try it again. Okay, this should be better. Okay? Good?
Yes, yes, perfect. Thank
Okay,
you.
great.
Sorry to
All
interrupt.
right, let me go back. Yeah, so I think the pictures are just too precious, so we got to go back for a second. So that's all of us, you know, way back when we were wee kids. You can see the school uniform is probably very similar, not quite, but it's the same. You can identify some people. So here's Rekha, Mahadevan. Here's Rekha, all the years later. Um, anyway, um, so this is a nice picture. Of our sir and madam, our principal, and I think Annie's mom, right? Your grandma, Jennifer, and Judith. Um, and I think one of the things I remember is if I ever wasn't behaving, all my mother had to say, "I'm going to go to your school," and I would I would automatically do the things that I needed to do to behave and be a good student. So I think Sharon really was just such a fantastic education. So I know you probably don't appreciate it right now, but I have all of my certificates and records from 20, 30 years ago. Um, One of the most important things Sharon taught me was we had elocution competitions, and then Sharon, I think, got me into a public speaking class, and my dad used to take me clear across town, to the Western Line. I remember for 7 weeks in a row for an hour, hour and a half, and we did effective public speaking. So one of the lessons I want to tell all of you kids is it is so important in your life to be a good speaker. Okay, I always tell my students every talk you give about the work you do is a job talk. So you should always try and be an effective public speaker because that will pay you lots and lots of dividends, and it's something you can learn. It just takes practice and good feedback and practice again. So make sure that you take advantage while you're in school to to speak effectively publicly and ask your teachers, oh, what could I do better? I left India 1986, so I thought this was my recommendation letter from Sir Thomas, from our principal. Just and I just thought it is like compared to the recommendation letters today, it is so understated, which was very interesting. And then we had the good fortune of visiting all of you a couple of years ago, so we can't wait to come back. And it'll be a lot of fun to see you all again. The only difference I saw when we came was you all said three across, and we always had smaller desks with two people across in four rows. But I was in yellow row, and I was glad to see the. I think the colors still exist, so that was kind of cool. All right. So growing up in Mulund, I just had an incredible time. I know Mulund has changed so much in the years. We grew up in Pushpamani, but really we didn't have much. We didn't have a refrigerator. We didn't have a car. We didn't have a television. Didn't have a phone. All of the things, like all of you probably have an iPhone. So things have changed dramatically. But there were some really important things that happened. Oh, let me stop sharing screen for a second because I have some video, and I want to make sure that when I share it, you'll be able to hear the videos. Let me do this again. Um, Share. Okay, now you should be able to hear the video when it comes up. Um, So one of the first shows that came to India. Whoops, I don't know what happened there. Turn that off. One of the first things that happened. Uh, this is not what should be happening. My apologies. It's switching me over. Okay, not sure why this is happening, but one of my first influences was this show. I hope when it plays, you'll be able to see it. Can you hear it?
Yes, we can hear.
Space, the final frontier. These are the voyages of the Starship Enterprise. Its continuing mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no one has gone before.
Okay, great. Try to pause it here. Stop. Okay, great. It's interesting. Yesterday, when I played this is not what happened. So I'm a little confused as to why this is happening that way. But anyway, so Star Trek was one of the first shows that came along with Different Strokes, which none of you probably know about. and, and this was my first introduction to America, but also to kind of just dreaming about being in space. And because we didn't have a television and Star Trek was always on, we had one channel, Doordarshan. Like right now, you have hundreds of channels on cable. We had one channel, and I would always go around the building on Sunday morning trying to find out where I could see Star Trek. But that's what inspired me. I just kept dreaming of going into space and visiting different worlds and meeting new civilizations. So that's where I think my interest in wanting to work for NASA and becoming an astronomer, an astronaut, really was born. So this was a big inspiration for me. Let me skip this slide. 1 second. Okay. So one of the things that Sharon did, Ishan has a question. Do you want to ask it quickly?
Yes, sir. Means I came 5 10 minutes early. So you are staying in America, sir?
Yes, I'm in Washington
No.
D.C. now.
Washington.
Yeah, I'll tell you in a
Okay,
second.
sir. Okay.
So one of the things we did from Sharon was really every year we would go on a school field trip and we would go to Nehru Planetarium. And these are some of the best memories for me because I just remember sitting and just learning all, you couldn't see the sky as well in Mumbai as you know, but just being able to be exposed to what space was about and feeling like you were able to see the night sky was a big influence for me as well. And then when I was, I think, 8 or 10 years old, I don't remember exactly when, I had my uncle and aunt who were living in America at the time visit me, and they gave me a book from the Voyager spacecraft. So Voyager are these two satellites that we have sent into space. They have left the solar system. They were launched in the 1970s. But as they left the solar system, they took these incredible, the best photographs you could ever see of all the planets in our solar system and some of the moons. And I remember just knowing this book, every single photograph, every single thing about the planets and the moons. I knew them really, really well. So I knew that this was my passion. That's what I wanted to do. And then when I was about 14 years old, we left Mumbai and landed in New York City. So you have to remember that we never went anywhere outside of India at that point, and all of a sudden the whole family left India and left all our friends and family behind and moved to a completely new country. So it was very difficult. The first few years were very, very difficult. I ended up living in Iowa, right in the middle of the country, for the first year because the family got all split apart. My sister had to come back to Mulund and finish her college in Somaya College in Ghatkopar or Vikroli. I'm not sure exactly where the college is. And I lived with my uncle and aunt in Iowa while my dad tried to find a job in New York City. And then once my dad was able to find a job and find an apartment, we ended up moving to New Jersey, which is where I finished high school. And then I went to college, to a small college back in Iowa again here called Grinnell College. And it was in the middle of nowhere, but I was so happy to just know that I wasn't going to be moving again. So it was really good to be at Grinnell College. And some of the things I'll tell you is that if you decide to come to America for college or go to Australia or New Zealand or anywhere else or stay in India and travel later for graduate school or work, the world today is just much more connected. You know a lot more about America than I did when I moved. So for me, college was a really big learning experience. And I just want to share with you some lessons that I want you to take away. So I know that in school in India, we always say uh, grades are important. And I think grades are important, right? I always, if I did not come in first, second, or third, I was always afraid to go home because I knew my mother would be very mad at me. But I will tell you that in the long term, the grades are not as important as learning. Okay, so you have to ask yourself, am I doing this simply so I can get a good score? So I can come first in class, or am I actually understanding what is being taught to me? And so that's important for I would say for people to remember. The second advice I have for you is don't chase success. Don't say I want to do this job because I can make a lot of money. I want to do this because it will be easy. You have to really ask yourself, what are you really passionate about? What is it that gets you out of bed in the morning? What is it that if you got no money, you would still want to do that job, and you should chase that passion, because if you chase passion, success will follow. But if you chase success, you might not sometimes be successful and you will be unhappy anyway. So for me, there's nothing more beautiful than sitting at a telescope late at night and watching the Milky Way go over me. And in this photograph, for example, is from the southern hemisphere. You can also see the two nearest galaxies to the Milky Way, the small Magellanic Cloud and the large Magellanic Cloud. And here's the Milky Way that we live inside of. It is the most incredible feeling for me even today. So I'm really, really happy that I decided to become an astronomer, because not a single day did I feel that I was going to work. It was something that I was doing for fun. Absolutely work hard. There is no there is no there is no way you can just keep not working hard and expecting success. It's not fun, especially if you're chasing passion. But you should also remember to play hard. Okay, so remember that once you work, you set up some time so you can also play and take care of yourself in terms of making sure that you enjoy life. For me, even though I went to college, this is my college's library called Berling Library. We would be working really, really hard all week. And then on Friday nights, we might go to a party, stay up late. But at 8 o'clock, we were back at work. I played golf in college, which I never would have been able to do had I not gone to a small college, because I didn't know how to play golf. But I was able to play golf and be on the golf team. We would go away on school trips every weekend, and on those trips we would leave on a Thursday and come back on a Sunday. But my professors would always tell me, well, you have to learn how to balance going away for a golf trip and your classes. You cannot get any break, you cannot get an extension. You have to learn to manage your time so you still get your work done and get to do your hobbies. So that time management is an important skill. Also, this is one of my favorite professors from my college, Kesho Scott. it's things will happen to you in your life that will make you unhappy. So in this case, we had a situation where there were a lot of racist slurs posted all over campus, and Dr. Scott brought all of us together for a workshop on for all the people who are not white. And we talked about racism in a very, very direct way. And so those lessons remain with me today. That we have to support each other, especially if you're not in the majority. So this is for me. I'm very lucky. I grew up in India, where I felt like I was part of the country. Uh, but it was something in America that's much harder, because you're not going to be in the majority necessarily, or if you go to Europe or Australia. So find good mentors and hang on to them. If you have teachers who've given you good advice, make sure that you hang on to them. And then I think at the end of the day, I'll tell you that what matters are people. So just remember, one day we're all going to die. So it's really important for you to know what's important in your life. In my case, one of my classmates, Tammy Zuwicki, was murdered in our senior year in college. And that had a huge influence on our class. And it brought our class very close together, but it also told us that life is very short. So you should make sure that you really pay attention to every day and enjoy it. Make sure that you're not wasting the day and wasting your time. Okay, so then I went from there. Pahal, if it's okay, can I go ahead and finish my slides? Can you hold off on your question for a while?
Sure. Sure, sir.
Okay, thanks. So after college, I went to University of Minnesota, and I ended up going into physics. So I thought about doing a history major, an English major. I went to a liberal arts school, which meant that um, I really, even though I wanted to be an astronomer, everybody told me you should really take English, history, literature, art. I took all of those classes. And that was really important. Because in order for you to be a good citizen of the world and be a good scientist and a good astronaut, I have to be able to learn to read critically, think critically, and speak well. And you can't learn that just by doing science your whole life. So I would strongly encourage you to think about liberal arts and making sure that you are paying as much attention to science as you are to English, as you are to music. You might not be good at everything, but it's important to really have all of those influences in your life for whatever your passion is. In Minnesota, I almost dropped out of college because I ended up in an incredibly racist, sexist environment. And all of a sudden, after being first in my entire life in class, I stopped going to classes, and I got a D, which is a horrible grade, almost failing. So I went down to my college and I said to my professors, I don't think I'm good enough to be a scientist, even though I had always been a good scientist. And they said, well, we know we've prepared you well enough, and you should quit, not because you don't think you can make it, but because you don't enjoy science anymore. And that wasn't true. So I went back to college, and I said, okay, we're going to take things into our own hands. And the students banded together. We filed a complaint against the department, and it launched me on a parallel career, which I won't talk to you about today, working a lot on racial equity, diversity, and inclusion. So I do a lot of work. I was a sexual harassment prevention trainer in graduate school, violence prevention specialist for the LA Commission on Assaults Against Women in Los Angeles. And I was also I was the director for the Office of Diversity and Inclusion at my lab in Charlottesville, and I do a lot of work at NASA on making sure that Black and Brown people are treated equally, which is not the case, in everywhere else in the Western world. So there's a lot of work to do, but it was because of this really difficult time where I almost stopped being a scientist. That impacted me. And what was important to me was that it wasn't my ability, but it was my environment that really impacted me. So after that, I did a master's. After I left Minnesota, I did a master's in physics education, but then I did a master's and a PhD in astronomy from the University of Maryland, where near Washington, D.C., right here. And my thesis was on molecular gas in nearby barred and unbarred spiral galaxies. And another time I can tell you all about galaxy evolution. Um, if you do a PhD, the typical next step is to do something called a postdoctoral fellowship that is typically 3 to 5 years long, and you might do one or two of them. And I went to Caltech. Caltech is the best place in the world to do astrophysics. It's right down here in Los Angeles, in Pasadena. And there you're an independent astronomer. You don't have, in graduate school you take classes, you sometimes teach, and then you do research. Now you're an independent researcher. And it was kind of the best time of my professional life. I had a great time traveling the world. I'll show you some photographs. And just doing research, and it expanded. I went beyond galaxy evolution and did a lot of work on gamma ray bursts and molecular clouds, and even Trojan asteroids near us. And then just very quickly after that, I ended up getting a permanent job as a research scientist working for the Spitzer Space Telescope, which you see here. And I'll show you a quick little video of Spitzer. And I was also leading principal investigator and a founding co-investigator on a couple of very large projects which are still going on today. I did a lot of work in radio astronomy. That was my upbringing. So this is a telescope, believe it or not. Each of these little antennas that you see here work together as an interferometer to create very, very sharp images at radio wavelengths. So this is the Owens Valley and BIMA arrays combined in a new telescope called Karma, which I helped commission. So this is at the dedication ceremony up in the mountains in your Big Pine in California. And then here I'm going to show you just a quick video of the Spitzer spacecraft, just for a minute.
3, 2, 1. We have ignition.
Rocket launches, it's thrusting out flames, and you're watching, and you have all those emotions, and the rocket goes along on this journey, and it deploys Spitzer.
The Spitzer Space Telescope is a member of NASA's family of great observatories. Spitzer is the infrared member of this family.
Spitzer has unveiled the infrared universe. It has enabled humans to see what our eyes could not see.
We see a whole new side to the universe that's hidden from us normally.
You can peer inside of clouds of dust to see the baby stars called protostars being born.
It let us see into more distant galaxies and see how the patterns of dust tell us about the motions of gas and the dynamics of gravity.
I'm just going to go ahead. I'll share the whole video with you so you'll have it.
We have ignition.
Rocket launches, it's thrusting.
In the interest of time, I'm going to go ahead and just kind of take you along in the journey. So after I was at Spitzer, where I did a lot of work looking at nearby galaxies with that space telescope, once the cryogen ran out of the Spitzer Space Telescope, I decided to change jobs again. So one of the things you will see is I keep changing jobs every 5 or 6 years. I moved back to the East Coast to Virginia and worked with a telescope called ALMA that we were just building. And I'm going to show you a really great video from that in a second. But it also meant that on the one hand, I was able to come closer to my parents who live in New Jersey. But the other nice thing was I was also able to go work in Chile and live in Santiago, but then travel up to the ALMA site up in the Andes Mountains as we built this telescope. So here's a nice video from ALMA. you the first image from ALMA that we made. So let me show you that. Remember that, this is a radio telescope, so we're looking.
There's stars and gas intermingling. The Hubble telescope sees bursts of star formation erupting, where great clouds of gas and dust crash into one another. But areas that look dark to existing telescopes are ablaze with light, as seen by ALMA.
You see there are these patches of dark regions which contain very dense gas and dust, within which the next generation of stars may already be forming. So you can see ALMA is really unveiling what really cannot be seen with any other telescope. It's a brand new window into the universe.
By 2013, the full array of 66 dishes will be complete. With early science operations underway, the telescope is beginning to unlock entire worlds of discovery. ALMA will provide astronomers of today and tomorrow with answers to our greatest mysteries.
So then, so that was a lot of fun for me to go work at ALMA. So I did that for about 6 years. And while I was doing that, I was also able to work for NASA on a different project, which is called the 30-year Astrophysics Visionary Roadmap, called Enduring Quest Daring Vision. So this is something I think many of you will be able to read. It's a committee that I served on with only 18 other people, and we were invited to lay out a vision for NASA astrophysics for the next 30 to 50 years. And this is pretty easy to read, so I would encourage you to read that. But what this did for me, serving on this committee, was expose me and bring me back into the NASA environment. And then the very next year, after I got tenure at the National Radio Astronomy Observatory and ALMA was up and running, I decided to then go back to NASA after working for the National Science Foundation. I'll just talk to you a little bit about what I do at NASA, but just to show you some of the great things about being an astronomer for all my life. It's really a fun life. I got to go to Onsala, Sweden on the top right. These are pictures I took. This is in Sydney Opera House. These are the Keck telescopes in Hawaii. Apologies for that. No, I'm getting this. Call my sister back in a second. Got to go to Greece. This is Venice and Brazil. And then this is me at the ALMA Observatory. So as you can see, I've told you kind of my career path. I went from Grinnell College to University of Minnesota. I remember that even though I was very, very successful, I almost dropped out of science because of the environment. Ended up doing another master's and PhD in astrophysics. I was a postdoctoral fellow at Caltech. One second. I'm just answering my sister because it's unusual for her to call me this early in the morning. And then I was, like I told you, an astronomer at the National Radio Astronomy Observatory. So in addition to working for ALMA, I also founded the Office of Diversity and Inclusion and set up a couple of programs to get more students from underserved, underrepresented groups into STEM. And then finally, while I was doing all this, I was getting faculty offers from all over the world, including South Africa. And I kept turning them down. I just really was enjoying doing science and doing research all the time at Caltech and in Chile and NRAO. All of these were jobs that I was offered that I turned down. And then eventually I decided that, after I'd done a full career in science, I decided to go over to NASA. So now I'm at NASA headquarters, which is in Washington, D.C. And NASA headquarters is kind of the mothership for all of the 10 NASA centers, where the centers are where the missions get built. But at headquarters, we make all the decisions on what NASA is going to be doing. So in astrophysics, we roughly get $1.8 billion every year. And with those $8 billion, we basically divide it up into different disciplines. And in astrophysics, we basically run missions, we provide research funds to the community, and really monitor and drive the science enterprise. So in my portfolio, I oversaw the SOFIA telescope, which is a flying observatory, the James Webb Space Telescope, which I have a really nice movie of. Just finished doing a study on the Origin Space Telescope. If it is selected, it will be launched in 2035, so many of you will be able to use it. The funny thing is, even though I worked for Spitzer Space Telescope as a scientist, I was then the program scientist for it, which meant that I oversaw the entire mission. So the person who used to be my boss and his boss and his boss were now reporting to me. So it was a very strange dynamic because all these people I used to work for were now working for me at NASA headquarters. A lot of time I spent is sending money to the community, where we send money for basic research, like even doing experiments in a laboratory for astronomy, to launching balloons with payloads on the bottom, where it goes into the stratosphere and looks down at the Earth to do work. I also oversaw the Hubble Fellowship Program, and then I do a lot of work with public affairs and diversity, equity, and inclusion. And as Jennifer said at the very beginning, over the last year or so, I've really been doing a lot more work in the Earth Science division. So I've been working with UN Sustainable Development Goals and trying to understand how I can do sustainable urban development, and working with a bunch of economists to try to understand the value of information from Earth observations for societal benefits. So I hope that kind of gives you a good feel for what we're doing. Just wanted. I know we're at the end of like 40 minutes and I wanted to stop, but I just want to show you the thing that I'm really excited about that I work on now, called the James Webb Space Telescope. So I'll just show you a very quick movie on that, and then I'll take your questions. So we're going to launch this observatory in October of this year. It will fly from, let me try to stop sharing my screen here. It will fly from Kourou on a European rocket called Ariane, and it will go to the L2 point. And we hope with a perfect orbit insertion that it will operate for 10 years. It will be like the Hubble Space Telescope, except like the Spitzer Space Telescope, it will observe in the infrared. And it effectively will allow us to look at galaxies from 7 billion years all the way to the beginning of the universe, 13.5 billion years ago. So I'm super excited because this is probably the most ambitious project NASA has ever undertaken. So I hope you all join us in October when we launch. We will have a live stream all over the world, and you will be hearing a lot about this next great observatory that we're going to launch. So I'll stop there. I hope that was interesting, useful. Happy to take any questions.
Yes, it is interesting.
Thank you so much, Dr. Kartik. I think we've learned so many new things, not just about you, but also about the field that you work in. And I'm definitely going to go back and read up more about many things that you spoke about in the talk today. I'm now going to invite students to please raise their hands, and Dr. Kartik, maybe you could take their names and they can unmute and ask you the questions.
Sure.
Yeah.
Okay, so I think I see, I think if this is working correctly. Ryan, do you want to go first?
Yes.
Oh, sorry, Daira was first, so I missed that.
Yes, sir. Good evening.
And
Good
Daira
morning,
and then
sir.
Ryan. Good
Good
morning.
morning, sir. Sir, I would like to just ask that do you still remember Gujarati and Hindi?
Yeah, I speak it all the time. So we speak Gujarati at home, and my Hindi is so funny. When I come to India, And in Mumbai, everybody knows that this guy's an NRI, because he doesn't speak Hindi all that well. But the nice thing is when I go travel elsewhere in India, and they're like, "You seem to not speak Hindi properly or with an accent," and then I just say I'm from Mumbai, and they accept it. Because we in Mumbai we have Marathi, Gujarati, and Hindi all mixed, so it's totally fine. Ryan?
Yes, even I am interested in astronomy, and I have heard about a theory called parallel universe. It's like similar to we can call it same just
Yeah.
like this universe. So has NASA discovered any evidences about that?
No, so we haven't. It would be very difficult to, because if it's a parallel universe, it's very difficult to imagine how light would travel from that universe to our universe, and that's all we can see, right? As an astronomer, everything we know about the universe is based on only two methods. All we do is collect light, and we collect light at different wavelengths. So by taking pictures at different wavelengths, like in the radio, in the visible, in the infrared, we're trying to get a good idea of what does an object look like in lots of different wavelengths. If I take a picture of you with a camera with your iPhone, and I take a picture of you with an infrared camera, you're going to look different, and you're going to be brighter in the infrared because you're a cold object. You only have 100 degrees Celsius as your temperature. But if I take a picture of the sun, if I take a picture of the sun, for example, the sun is so much brighter. It's 6,000 degrees on its surface. So it is brightest in the optical. So everything we do depends on light, and then you can take that light and you can break it up into a spectrum, and then you can tell what it is made out of, what is the chemical composition of the object. That's why we do spectroscopy. So imaging and spectroscopy are the only two tools available to astronomers. Unlike physicists or chemists or biologists, we cannot do experiments. We have to wait for the universe to speak to us. So imagine that there's a parallel universe. How do I find out there's a parallel universe? It would be very difficult because the light has to come from that universe to us. And that there is, because I can only see the edge of the universe, because that's also the edge of time. It's not something we can figure out. However, having said all that, I would encourage you to look up a paper by Ranga Ramchari, who's a friend of mine. He's at Caltech right now. He did publish a paper maybe 3 years ago, where he saw in the radio sky, we're looking at radio wavelengths, one part of the sky seemed to have slightly higher signal than other parts of the sky that he cannot explain. One possible solution for that is, as these universes collide with each other, there might be an overabundance of some kind of hydrogen and reionization, and that might be a signature we can see. But he's never been able to prove it, and most people think it's kind of a crazy theory anyway. So that's the best we've done so far. So it's all theoretical. Janelle?
So, what is a black hole, and how much information have you known about it?
Yeah, so black holes are very, very common. A black hole is the ultimate victory of gravity. If you take all of the mass of our sun and you put it into a single point, you could possibly have a black hole. Typically it's the Chandrasekhar limit. Subramaniam Chandrasekhar is an Indian astronomer, was at University of Chicago for many years, won the Nobel Prize for his work, came up with what we call the Chandrasekhar limit, where if you have more than 1.3 solar masses into one single point, it would become a black hole. So imagine that you have a big rubber sheet and you put a marble on it, the rubber sheet will bend. Imagine making that marble bigger and bigger and heavier and heavier. So then you take that rubber sheet and you pull it all the way down. Now, that rubber sheet is space-time continuum. That's what we see and live in. So if you have if you go to that, if you try to go towards the rubber sheet, as if you roll a marble down, you will see the marble will start rolling around the center, right? At some point in a black hole, that depth, that rubber sheet is pulled down so deep because it's a black hole that once light goes inside of it, it cannot come out. So that's the theory of a black hole. We see black holes everywhere, right? We have seen intermediate mass black holes, which are star sized, but every single galaxy, including our Milky Way, has a black hole in the middle of it. We call them supermassive black holes. I've studied them. We study them because we can't see the actual black hole, but we can see the very bright accretion disk around it. And so they become visible in the X-rays. And sometimes black holes have these big jets that come out from the center, so we can study them in the radio as well. How they formed, we don't fully understand. We think it's mergers of very many massive stars at the beginning of time and universe that created these supermassive black holes today. Chandrasekhar's limit is a little bit uncertain now. We used to think it was 1.3 solar masses, but now we see stars that are as massive as 2.2 or 2.5 solar masses that remain stable. So we don't fully understand the physics. There's still a lot more to be done. But with the new telescopes like LIGO and LISA, we're going to understand a lot about black hole physics, because as these black holes merge and they send gravitational waves through the universe, we'll be able to detect them. One of the LIGO experiments is in India. So if you're interested, you should check out LIGO India and see if you can do an internship. It's a good way to learn about black holes. Dishika?
Yes, sir. There is you have told that there are two types of black holes, right? The small type of black hole and the big type of black hole. So you say that in the small black hole there are no chances of going out of it, and in the big hole you have some chance of getting out. So is that really true that in the big hole, once you are getting going, there are chances of coming back? Is it true?
No, neither of the black holes. Once you enter the event horizon, you cannot come out. That's just I just meant that the way we detect them is by the material that is outside the black hole, outside the event horizon. That's what we are seeing. And we are trying to understand what the black hole is like by looking at the material outside the supermassive black hole. With the intermediate and the smaller size black holes, they're unlikely to collect any material, so we can't directly see them. The way we detect those is when they pass in front of other stars, and there's an event called microlensing. So you will see as a black hole, which is dark, you can't see it, passes in front of a star, that starlight goes around that black hole and it's amplified for a short amount of time. That's how we can tell that there are small black holes. Does that make sense?
Yeah, a little bit it makes sense, yeah.
Okay.
Because yeah, I understood. Because this starlight is a little bit bright, so we are able to see because of the light. We are able to see the black hole because of the light.
You're able to see the black hole because of the amplification of light from a background source when it's a small or a big black hole. But for the big black holes, because material as it comes close to it gets trapped in gravity around it in an accretion disk, and that accretion disk, as more and more material accumulates, becomes very, very hot. So it will emit in the X-rays. The X-rays are what we detect, and by inferring how much material there is and how quickly it is moving, we can tell that there must be a black hole there.
Oh, okay.
Material falls into the black hole, you can't see it, it's gone.
Yeah.
Let me take some other questions because we have a lot of hands. Okay, sorry, Dishika. Rashi and then Janil.
So have you discovered any other life? Means the proof of any other life?
Yeah, we haven't discovered any proof of other life yet, but I think it's just a matter of time. As you know, we've now discovered water on so many parts of the solar system. So not just on the Earth, not just on the moon, but on Mars, on Titan, on Enceladus. Our solar system has water almost everywhere. And so we think that if there's water, there's likely to be life. And the Perseverance mission that we just launched and landed, which you probably saw, is going to look for evidence of life on Mars. In astrophysics, we're trying to understand whether life exists by looking for biosignatures. So what we're trying to do is we're looking at planets around other solar systems and trying to take spectra of their atmospheres to try to understand whether there's any evidence of life inside of it. So if you took a picture of the Earth from space and you were taking a spectrum, you would see light reflecting back, and then all of a sudden in the infrared, you would see a big dip. And the reason for that big dip in light is because that light is being absorbed by plants and chlorophyll on the ground. It's called the red edge. So that's one of the signatures that I think we're looking for to see if there might be life. Another way astronomers are looking for life is by searching for extraterrestrial signals using the SETI experiment. We've been looking for 30 years. We haven't heard anything. We've sent out a signal in 1975. We used the Arecibo telescope to send out a very strong signal towards the Hercules cluster. But because astronomers had their calculations wrong, they missed the cluster because they didn't get the proper motion of it right. So by the time that signal got there, the cluster had moved out of the way. So we make mistakes, that happens. So I hope
Yes.
that answers your question. Let me try to take as many questions as I can. Yeah,
Yes,
Janil?
sir. So, but where might be a sign that human life can be formed? It means you said it, but in Mars it is like that 85 years the freeze temperature was there. In Mercury, no life can be formed because an acid, I don't remember its name, sorry sir for that, but that is a very deadly acid that might fall as rain on Mercury, but due to its very hot temperature it doesn't, and it evaporates in the middle of air while falling.
Yeah, so the issue here is, we only know what we know, right? So you always try to say, well, if I was there, would I live? Or if I was there, could I breathe the air? That's possible, but there might be other forms of life that might exist. So we don't know that yet. So with Perseverance, we're going to look for signatures of things that are what we call biological signatures. So, or when we look for signatures in gases, we look for abiotic signatures. So, for example, we look for disequilibrium between methane and carbon dioxide, which can only happen given the chemistry of atmospheres only when there is life form of some sort that are, taking in carbon dioxide and breathing out oxygen. And we don't know what kind of life that might be. It might be human, it might be microbial, very likely it's microbial. That's what we're looking for. So I meant to say Janil Joshi, but I'm glad I got the other Janil. So Janil Joshi, go ahead next.
Firstly, sir, feeling overwhelmed to talk with you. So I have only two questions. First is, were you included in the Mars Mission 2020?
In the Mars mission? No, because I'm in astrophysics. On the other hand, we work from the Science Mission Directorate, so we oversee all of the science in America. So I was involved in the sense that, from headquarters, we direct the mission. So in that sense, yes, but not on the ground. But you saw people like Swati Mohan, as the landing manager on TV.
Excuse me, sir.
I don't know who that was. So Janil, you want to ask the second question, and then Rashi?
Yeah.
Hang on, Ishan. Go ahead,
So,
Janil. Ask your quickly. Ask your.
Have you watched Interstellar?
Yes, I didn't like the movie. Other people did. I didn't like the movie. Okay, so let's go Rashi and then Samruddhi.
Yes, sir. Sir, I just wanted to ask you, how do you feel about colonizing Mars?
I think it's a terrible idea. Let's hope we don't do that because we've done a really terrible job colonizing the rest of the world. So there was a really good seminar. If I can find the link, I'll send it to you, that a friend of mine, Lucianne Walkowitz, led when she was a fellow at Library of Congress, where there's a lot of discussion on what are the ethics when we go into space. And I just had a discussion yesterday where we're thinking about NASA 25 years from now. And I said to the team that's working on it that if we had something like if we had something like the prime directive where we agreed make sure where that sound is coming from.
Teaching how to read
Sorry,
and
please
write.
mute yourselves, students. Those who are not speaking, please mute yourselves.
Yeah, so I would say if we had something like the prime directive where we agreed not to harm any other life form or damage the system, then that would be good. So I hope we do that. Samruddhi?
Yes, sir. So I'm also very interested in astronomy, and I read an article. So in that article, it was said that on the other side of the black holes, there are white holes, which give out the matter taken in by the black hole. So I wanted to know if it is true and if you have ever done any research on that.
Yeah, it's a theoretical construct that there might be white holes where black holes can emit their articles, but as far as we know, we've never seen one. So it's just theory. It's just like the theory of parallel universe or the theory of dark matter. I mean, that's very important in science that people think about these things, but we have no evidence right now that that's the case. If there is a way for things from the black hole to come out, they would be completely destroyed because the gravitational forces are so strong that you're going to shred any matter. So if anything, if there is such a thing, I think it's unclear that anything could survive passing through the event horizon of a black hole. Even if you got near the black hole, your head would get stretched, so far you just get pulled apart. But a good question I always ask students is, if tomorrow the sun became a black hole, would anything happen to us? Nothing would happen to us because the gravity is still the same far away from the black hole. It's only when you get very close to the black hole that it would change.
Thank you, sir.
Daria, you're welcome. Daria, and then Kashish.
Yes, sir. I have heard that they are building a hotel in space. So is it true?
Yeah, right now access to low Earth orbit has become very cheap because of companies like SpaceX and Blue Origins that NASA helped get going. So there is right now a new venture that is trying to build a hotel in space so that people can go visit. They are on a very extremely tight timeline, so I don't know if they'll be successful. But look at how much SpaceX has accomplished just in time.
Excuse me, sir.
Thank you, sir.
Go ahead, Jenny. Wait,
Sir,
I'm not sure who was it.
Sir, do you believe in the Big Bang theory?
Yeah, there's not a question of belief. We have so much evidence that the universe was part of a very small, hot, dense object, and it's still expanding today. So I would not call it a theory. That's what we see. Ishan,
No, sir, because some scientists were opposing it.
There will always be people who say climate change isn't real, right? So you have to just go with whatever science tells you, wherever the data is taking you. Okay, so let me try to see if
I know that we've hit the hour, so please don't feel pressure to take all the questions. Really nice of you to give us an hour of your time.
Yeah, let me take one more.
So can I ask the last question? So can I ask the last question? Ma'am, sir, can I ask? So can I ask, please?
Okay, I'll have to come back clearly, Jennifer. You're gonna have to organize the second one. Unfortunately, I have another meeting.
Yes.
So why don't I take one question from Vanshi, and then I will come back and answer your question.
Vanshi can ask the last question, and no more questions after that, students. Vanshi?
So I wanted a suggestion from you that to be an astronaut, I had an interest for the study. To be an astronaut, you have in NASA. So what interviews you got from them, or the questions were asked to you?
I don't think I understood the question. Maybe you can type it in.
Yeah, Yadvesh, maybe you can type in your question and we'll try to get a response from Dr. Kartik and get back to you.
Yes, sir.
Why don't you ask your last question and then I'll...
Yes, sir. Telescopes reminds me of upcoming mission of NASA, which can see 13.8 billion years back. So, are you part of it?
Yeah, James Webb is one of my missions, so that's what I'm overseeing right now. So our team is working towards getting it launched. So that was the last video I showed you with the big telescope, which looks like has a gold mirror. That's a tiny amount of gold that we put on top of the mirror to protect it from micrometeorites. And the mirrors are made out of beryllium. It's a very lightweight mirror. That entire telescope that I showed you is 33 feet in diameter. So it's like 6.2 meters or something like that. So it's enormous. It's going to be 3 times bigger than the Hubble Space Telescope. And not only are we going to launch it not just around the Earth, we're taking it all the way to the Lagrange point, 1 million miles away from Earth. So that it's because it's in the infrared, we needed to be away from the heat of the Earth. So I gotta go. I'm so sorry. But I'm happy to come back, Jennifer, if we want to do a revisit.
Yeah. Sir, I send you the question.
It was a pleasure.
Sir, last question, please.
Sir, can you come back again?
Students, we
Sir,
try
can I ask a question, please?
we will try and organize one more meet with Dr. Kartik. Kartik, would you have one moment for a small vote of thanks, or do you have to rush?
Sure. Yeah, I'm gonna log into my other machine here as we talk, so you
Yeah.
can.
Krisha, can you, over to you, Krisha, if you're on this call.
Yeah.
Yeah.
May I continue?
Yes, Krisha, please go ahead.
Okay, so good evening to everyone present over here. And as we have reached the end of this webinar, I, Krisha Setia, take this opportunity to express my gratitude into words. First of all, I would like to thank Dr. Kartik Sheth for visiting and enlightening us with his knowledge. Today's webinar was full of knowledge and interesting things which gave deep insight to the topic. It was quite inspiring for the students who wish to pursue for scientists and astrophysicists. The limelight of the entire webinar was don't just chase success but chase passion. It has really instilled a lot of inspiration in us to to practice and follow our passion and not just run behind being financially stable. I would also thank the entire management staff for organizing the webinar. Lastly, I would wholeheartedly thank on behalf of entire Sharon family for sparing your time from your busy schedule and encouraging us for our future.
You're so welcome. I look forward to coming and joining you all again. So I clearly we have too many questions, so I'll have to come back.
Thank you.
Okay.
Thank you, Kartik.
See you
for
later.
making this
Bye.
time.
Bye, sir. Bye, sir.
Thank you.
Thank you, sir.
Bye,
Bye,
sir.
Bye, sir. Thank you, sir.
Bye, teacher.
Bye, sir.
Thank you, sir. Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir. Thank you, sir.
Bye, sir.
Thank you, everyone. Thank you for joining today. Sorry we couldn't take all your questions, but hopefully we'll be able to meet Dr. Kartik sometime soon again. Thank you, everyone. May I end the call now, Jeshi Madam?
Yeah, thank you, Jennifer, for organizing such a wonderful webinar. I think children, most of them enjoyed. They had so many questions, queries, and as Krisha also said, and as Dr. Kartik has said, that you should never chase success, but your passion. Okay, I think this word must have gone deep into the hearts of each and every Sharonite, and each one of them will be working towards it. And he said grades do not, he said another very important thing, grades are not very important, but as long as you learn things, that is very, very important. These are the two things which he said. I think it has really gone into the minds of a young, we can say, budding. Many of them will be scientists here. Hope you will be organizing more such webinars. We are really grateful and thankful to the management. Jennifer, you really worked hard to organize this webinar. It was really having great fun, and really we learned so many things. As a teacher also, I got a real insight of how his journey was, and totally like how he has struggled. It was not was a very easy journey, but he never gave up, and he's now a renowned and a known scientist. It's really great to have Sharonite at such a great position, and I feel proud to be a part of Sharon family. Thank you very much. Thank you, Annie Madam. Thank you, everyone.
Thank you. Thank you, everyone. Bye-bye.
Bye, ma'am.
Thank you.
Bye, ma'am.